I don't know. I'd have to look that up special. But the average is April 28th. I didn't realize it was that late. That's pretty late.
All right, live stream is still going, so whenever.
Yeah, I bet it was. Yeah, I bet it was.
We're ready to go whenever you're ready to go. I guess whenever.
Yeah, whatever match you want to look at that correlation.
I'll fumble even and try to explain.
We're ready whenever.
Okay. Is this microphone working at all?
Is it turned on?
Yeah. It seems to help
Exactly. The first question also is something we had barely talked about. And give you maybe beyond.
I'll start with Greg sits down. Okay. This idea is just developed over the last maybe 10 years or so, but the elements are in the air already. It's just when the polar vortex is in a high index mode, whether you call it a northern annular mode positive phase or an Arctic Constellation positive phase, it means there's lower pressure in general over the pole. The vortex is stronger and it goes round and round, and it generally tends to bring warm air in the winter off the Pacific into North America and off the Atlantic into Eurasia. So mid-latitude cities can tend to be slightly warmer during a strong polar vortex, and the opposite can happen when, let's say there's a sudden warming and it wobbles and a lobe comes overhead. Then for maybe a week or so, you might have colder weather in Madison. And so what I've done over the last 10 years, every once in a while, especially 2013-14 was a good one, been doing it the last few years, is just download daily maps of 850 Kelvin potential vorticity and checking it against Ed Hopkins' record of Madison daily average temperature. And so I thought I'd try to do a little bit more detailed study on that, and I pieced this together kind of late at night, and I haven't really tried to describe it before. So
Is he loud enough right there? Can you hear? Just checking. Should I turn him on? Turn him on. I'm going to just turn you on.
Turn up the microphone? Sure. Okay. So this is just happens to be a picture from 2020. It's December 16th, 2020. It's at 5:50. I'm not going to show any more of those. What I'll be showing is surface and the 850 Kelvin potential vorticity level. To look at potential vorticity at that level, that's about 30 kilometers altitude. So horizontally, that's not very far. It's like 30 kilometers off, but it's vertical. So I'm going to correlate a point overhead, 30 kilometers overhead over Madison, using ECMWF 10 hectopascal. It's about the same as 850K potential vorticity, and that has an 8-kilometer horizontal resolution. It's been available since 2016. So I can look at the last 2 years of that. Just sort of generically interested in how the surface is related to the polar vortex. So we can look at these two winters in detail, and thanks to Ed, I believe it's Ed Hopkins who compiles these. And so this is the starting of the 2020-21 winter, and we can see that it was below normal here and here, so this is kind of mid-December and late December. But the thing that I've noticed is sort of an intuition is there's an interesting thing that happens if there's kind of quasi-weekly or even longer sort of periodicities in these signals. That is, if it was really cold and then warm, and then really cold and then warm, and really cold and then warm during this period of time, that's a different scenario, as it turns out. So that's mid-December, late December 2020, a little bit cold. So then this is the rest of that first winter. It's 2021 now, and you can see, not too much variability, some kind of week-to-week variability here, but look at this spectacular period of time, a couple weeks in mid-February where it was quite cold. So that was the first winter. Now we can look at the most recent one, the second one we're looking at. Oops, sorry, that's starts over here, right? So December 2021, kind of warmer than average, but maybe some kind of quasi-weekly period of oscillations here, perhaps. to see. And then the rest of this winter, you can see here, this is the different kind of behavior that I was sort of noticing, sort of spiky up and down on more of a 3 or 4 or 5 day time scale, similar to synoptic waves coming by in the troposphere, perhaps decoupled from what's happening in the stratosphere. You can take a look at that with correlation, simple correlation coefficient calculations in an Excel spreadsheet, and check them with MATLAB. So this is the first one that I tried, and Shelley Rowe was very kind to painstakingly pick out an individual point over Madison every day. So this is 120 points of data for 1 year, and then another 120 for the other year. And I just picked off whole columns of daily mean temperatures from Ed Hopkins, so that part was easier. This just reproduces what I showed you from Ed Hopkins' plot in blue. This is for just a few months ago, so this is this winter, December of 2021. And blue is mean surface temperature in Madison in Fahrenheit, and that scale is over there. So you can see it was kind of cold here, and then kind of warm here, and kind of cold here, and then warm and cold. Okay, so this is the end of December of this year, this winter. And then if you plot the potential vorticity at 10 hectopascals, which is close enough to the 50K surface that I'm not kind of worried about it, maybe a kilometer or 500 meters off in altitude. And that's in some people call this ochre, I guess, or yellow, or maybe it's pinkish or reddish. But it's a different color than blue. And it looks sort of anti-correlated, and the correlation coefficient is actually minus 0.67. So if you square that, maybe 0.7 squared is almost 50%. That means that from a statistical point of view, if you know 10 hectopascal PV, you can explain 50% of the variance of the weather on day-to-day variability in Madison for December at the surface, which is kind of extraordinary. I thought, that's very motivating, but perhaps a little bit lucky, and I was expecting, in general, smaller coefficients. So, maybe before I show you the next plot, and I think I need to boost this back down a bit, it's sort of ringing. Let me exit this and show you the sequence of PV. It's not really 850, it's 10 hectopascal. Oh wait, no, this one is. This is from a different website. So this is GFS data, and it's compiled at CPC. So these are the maps that I usually look at. So you can make a simple movie this way. And then for some reason, it's going to load in this on top. I don't know why it's doing that today. All right, so this is a daily snapshot of 850 Kelvin PV, which is close enough to the 10 hectopascal level where we're picking numbers off at 8-kilometer resolution horizontally. So this is early December, and you can see, a little bit of wobbling of vortex. And indeed, when that polar vortex lobe is over us in North America, as it was for a long time in parts of 2013, 2014, and also that subsequent winter, and also about 2 winters ago, it was pretty common. So then sometimes you have a period of time where really low PV is kind of swirling around in this surf zone, and we can check the values. So if you get down into the oranges, you have PV values like 80 times 10 to the minus 6. What is it, Kelvin's?
I can never remember
That's
the
a hard
units. PV
PV units. Kelvin meters per second per kilogram. Kelvin. So, sorry. And here we go. Kelvins per meter squared, kilogram per second. But sometimes values can be up in here, so, blue, that would be more like 1,000 of these PV values. So it's a big range. It's really quite striking. And you can even see when these little filaments circulate over Madison that sometimes you get big spikes, or upward or downward, and that's really fine-grained features. So if you wanted to, you could smooth this data in time to compensate for these little filaments that tend to go overhead. And so there's a spatial temporal trade-off of fine grainness. Another approach would be to do like a band pass, which would really target this weekly stuff that I think is probably relevant, rather than the day-to-day variability for connecting with the polar vortex. So we can just advance through this, and here it comes back again overhead. This is December 13th, it was cold in the middle. And then it got a little warmer, I think. Well, anyway. So when I look at day-to-day values of this, and then I look at the plot showing the temperature of Madison, I convinced myself that there really were periods of time when the polar vortex was overhead that it correlated with the outbreak of cold air at the surface. So this is the idea of kind of a large, massive, three-dimensional wave-breaking event, where if you have a surge of warm air over the pole, ozone rich right over the pole in the stratosphere, that's somehow compensated at the same time by an increased waviness and a lower index and more locations where cold air is coming southward, where the lobe of the vortex is overhead, might coincide with where the cold pool of air is extruding kind of out of the Arctic. And then I started to look, at every day going on and on into January and February, and it seemed like things were kind of working out well, that there was going to be a high negative correlation between potential vorticity being large and cold temperatures over Madison at the surface. And there's a fair bit of activity. Where are we up to? This is February 12th. Turns out that February is fairly highly correlated, actually, in this sense. And then here's the start of the demise of the vortex this year. It broke out. This is March 7th. It circulated around overhead, and I started to convince myself that there really were daily variations of surface temperature related to these little strands floating around in the stratosphere. It's like, oh, here comes another lobe, and it comes around again. And that actually did seem to me to correlate with cooler times in Madison. Not dramatically so, but kind of a lesser magnitude. So now I'll show you the result for the whole winter. So here's a nice reassuring minus 0.67 correlation for December of this year. And this is for the entire year. The correlation is minus 0.04. So that's a little bit deflating. Not too bad, because there's still this idea that there can be periods of time where there are clear kind of longer period variations where you do have a high correlation. This period is minus 0.67. The whole thing, you kind of see a nice kind of minimum in the winter time, a lot of fine grain variation. Well, that's the way it turned out. Yeah.
Well, the polar vortex is tied strongly to the polar night when the sun sets, and it's not going to be there much during the summer, right? So.
Right. Oh, this is just December through March. But.
Okay, I thought you were doing the entire.
Yeah, no, I meant so just the 4 winter months, like December, okay. January, February, and March. So yeah, this is just getting right up to just last week or so.
I see. Okay.
So it doesn't have this next sun, like whatever you've talked about.
Oh, I see the variability is high at the beginning, Matt, in both time series, and then it's weaker even at the end in both time series. If you think about a local average.
Yeah, just the range is pretty substantial here. And then the grass has a smaller magnitude all the way throughout. And I thought, hey, I wonder if this is consistent with the high index NAM, or high index Arctic Constellation, where if the polar vortex is largely confined, every once in a while it kind of dips over Madison every once in a while on a kind of a small amplitude basis. Whereas during this period of time, it was more asymmetric, and there were large lobes that extended over Madison right here.
So if you were to do the same analysis over a number of years, and you kind of looked at the long time series, but then put on top of it the range, are there pulses in the range? And in those pulses of big range, are they times where the correlation goes up?
I agree. So there's the range, and also if we did a power spectrum analysis, there would probably be a mild peak relating to this period of time that has periodicities that are a little bit longer than a week.
Yeah, and then they get shorter everywhere else. Yeah.
So, kind of following along with that, I'm wondering whether the fact that you see these high correlations during the periods where there's a long, about a week or so variation from warm to cold and so on, does that indicate that you have a really large-scale feature that has a deep penetration depth from the middle lower stratosphere down into the troposphere?
So It makes sense, the part that you're saying, it makes sense that in the stratosphere there's filtering, so shorter waves don't get up into westerlies, but longer ones do, and these lobes tend to have quasi wave number 2, wave number 3 sort of scales. So if something like that is swinging overhead, and it does influence the surface, then it would have a longer time scale associated with it because it's a larger scale feature, whereas the troposphere naturally has, wave numbers 5 through 10 or higher that are making for greater temporal variability from day to day. The part that I don't get is the vertical coupling, and it's a really prominent notion that there is such, but my tentative conclusion from this is that that coupling can turn on and then turn off. And that turning it on depends on, maybe just simply depends on, if there's a lobe of the coronal vortex overhead, then it induces a period of time where there is a vertical coupling.
Right, because in the loop that you showed, or that you went through the series of maps, at the very beginning of December, you had this huge extrusion of dense vorticity across the pole, but for much of, it seemed to me, January and February, it was more isolated in the blob closer to the pole with very little latitudinal extent. It was just
That's my
circular
impression as
blob.
well. Yeah.
So you didn't really have an extrusion to couple deeply, it wasn't a long wavelength. But
Yeah, not too much anyway. But so we did this analysis for the previous year that I can show you, and a similar result, that you can cherry pick subsets with long period phenomena to get substantially large negative correlations, but well, I'll show you. So this is just temperature alone for the previous year. This is December 2020 through March of 2021. And there was this nice excursion right here in February that was notable, one winter ago. And so if you look at this analysis, you find that the correlation is even closer to 0, minus 0.008. There's like, if you're hoping for something like minus 0.5, that's not so high. But I did this one first. I was thinking, wow, this is great. And I was looking through the daily maps, which I don't have queued up, but I could find them. This seemed like a nice period of time, and so I did that one first. It was minus 0.45. Not minus 0.67, but pretty good. However, this entire winter is 0. So I guess it's an intriguing signal.
Is there maybe a conduit level map between the surface and 10 hectopascals that's particularly sensitive to assisting the physical communication or something? Or
there's the idea of the rigidity of the two-dimensionality of flows under rotation. That there's a vertical rigidity that if you throw dye into a non-rotating tank, it'll be blobby three-dimensional like the tropical clouds. And then if you rotate the tank and you throw dye in it, all the strands that you see looking in plan view are actually vertical sheets. So there's some observational evidence in laboratory work as well as the geophysical ocean and atmosphere that sometimes this happens. A related concept is, I guess I don't remember the name of it very well because I haven't studied it enough. It's sometimes you mention it, Michael. The vertical coupling kind of theory, like if you grow a mountain, then all of a sudden the whole thing will spin anticyclonically all the way to the top. A Taylor column hypothesis approach may have some bearing to this, but I think most of the theories relate vertical coupling to the idea of the stiffness of rotation will cause the vertical Rossby depth to be greater. And then that implies PV anomalies will have a greater action at a distance, is one line of thinking. There may be some radiative coupling, like if you have a lobe of air overhead that's, well, I don't know about this. If you have a cold pool of air below, then hydrostatically you'll have a trough aloft, even all the way up to 10 hectopascals. Then radiatively, if it's cold at the surface, the air in the stratosphere communicating through infrared will tend to get colder too, maybe. Don't know. But, so here is the Arctic Oscillation Index. You might think, well, why look at just one point for PV at 10 hectopascals right over Madison? Maybe something broader might be a better index of when it's cold in Madison. Right? So here's the loading pattern for the empirical orthogonal function that is, this is 1,000 hectopascals, so this defines what the Arctic Oscillation is. And you can do it at different levels, but this is the AOF, the EOF that people use at CPC. So here's the Arctic Oscillation for this most recent winter. And it does tend to be somewhat positive, which is kind of what Michael deduced kind of intuitively, and that's sort of my impression as well. But what that means is this is lower and this is higher, so that the jet in between is stronger, and it goes round and round and round, and it's very stronger than average. But sometimes it might dip over Madison and back, but there aren't going to be any huge oscillations with a large lobe over Madison for a long period of time in a higher index mode.
Yeah, you know,
Here's the low index mode period where the correlation between Madison PV at 10 hectopascals and surface temperature was high. It was high then, when the Arctic Oscillation Index was low.
you know, the job of making it feel like winter around here this winter was carried by the troposphere in northwesterly flow that might emerge from this broad structure, but it was never reinforced by an excursion of the so-called polar vortex that we talk about in the media now, but the real polar vortex is here, and you're showing that. It was never encouraged or supported by that. That's interesting.
Yeah, it was there, and it kind of flirted with Madison, but didn't really
Yeah,
go
exactly.
full.
Yeah, so we had to rely on
Except for
development of
December.
waves in northwesterly flow, which kept us cold, but not unduly so. Very interesting.
I only have a couple of other things that I found last night was about the Arctic Oscillation. So this is the same plot of the Arctic Oscillation Index, which is that EOF, and the coefficient is a function of time. So to interpret this, during this period of time, there's a strong polar vortex, and the darker the colors, the greater the number. It's normalized, so it's in standard deviation form. So a blue color represents a strong polar vortex, and then generally speaking, blocking anticyclones do form, but they're not real robust during that period of time. Whereas when the polar vortex is weaker, then that sort of thing does happen, and substantial long-lasting blocking highs, or the trough in between can maybe last a long time. And then, so this is another view of the Arctic Oscillation for this year. And just to point out that they do try to do different scenarios of forecasting, 7, 10, and 14 days. I just found this, I didn't know they did that. And they try to track it and see, based on how the whole world is doing, can they infer what this EOF will do into the future. And then this Arctic Oscillation Index does vary on a longer time scale. And I don't know if there's any information in here that is really something that can glean immediately, but I do remember, well, in the 50s, 70s, when I was growing up, there tended to be more snow in North America, or in the lower 48 than in the last while. I don't know if this is a period of time where that's the case also. Whatever that says. 2010, I don't know. There may be some interesting interannual things to look at as well. That's just showing where we are. This is up at 10 hectopascals for 30 kilometers or 850 Kelvin in an attempt to try to correlate with the surface. Yeah, so the vertical coupling may have something to do with laboratory tank experiments, like that. That's somehow a deep baroclinic thing. You have warm air going poleward, that'll lower the center of mass. You have cold air sinking equatorward, that'll lower the center of mass too. So just an initial look at these correlations and the successes and frustrations so far.
Very interesting.
Thanks for sharing. Thanks, Matt.
Thanks, Matt.
But it's a really rich problem, so maybe you'll get some ideas and think of another way to think about this, and it could be a thesis or something.
Yeah,
Thank you.
very interesting. Thanks. This I don't use it. It's really become a workshop on the winter, which is great. Trying to understand all these aspects of the winter is for me, the most fascinating thing in science. What happened to our I don't care. John, the corners. So I'm only going to talk for a couple minutes about the current weather and this week's weather. I think Pete had a satellite movie for this week, and it's really been a great week for active weather across our region especially. But there's a beautiful cyclone off the Atlantic coast. Here's our storm from the other day.
That's the one.
Earlier,
it's like,
sorry.
like Wednesday. It's
Yeah, that's the
basically
earlier
a
one.
cutoff that's been sitting over us the last couple of days.
Yeah, so we had I had a couple of great views of that thing in class on Wednesday. It was just spectacular. Beautiful cyclone, cloud head spinning around over the western part of the state, and then you can see in the infrared how the clouds are really low clouds, especially today. This is a widespread region of low clouds. And the circulation, we'll see this reflected in the upper level charts, the circulation around this thing has taken over the eastern half of North America as a couple of days have gone by. And don't neglect to see when it peeks out behind the clouds, these really interesting eddies there in the North Atlantic, or the Eastern Atlantic, Western Atlantic, sorry. You can kind of see them pop out of the clouds right in there. Beautiful eddies in the ocean. And they don't move while the clouds move past them. So this has been a really good week for a couple of different storms. And I think I'll just make one small comment about this. We were talking last week about the potential for snow on Wednesday or Thursday and Friday, I think, and sure enough, it happened. We didn't get measurable snow. We still need about 8 inches to get that 9-inch total for the,
Yeah, I was gonna say that I saw some cards this morning that had at least half an inch, which surprised me.
Maybe we need a little less than 8 now, so I don't know what the what's reporting, so. Yeah, that's good, so we got a chance, but it looks like the big chance for snow in the near-term forecast is just to our north, so we may come tantalizingly close to breaking out of the boring winter with the final piece of hardware, but I don't think we're gonna get it. And then I looked this morning early to see whether or not we haven't had 80 degrees yet, and how late do we usually have to wait to get to 80 degrees? The average first 80 in Madison is April 28th, so we have plenty of time to wait for that. So
I'd settle for the 60s.
yeah, I know, I really would, but we have probably no reasonable chance, or certainly no reasonable prospect for predicting a chance of breaking even the mean. But the all-time latest one is sometime in early June, so there have been horrible springs here apparently. Anyway, so a beautiful picture of our cyclone over us right now. And let's move on to maybe the West Coast satellite, current satellite, just for a moment. And then we'll go to the radar. So the other interesting weather that's kind of cool, how you can blend what you see on the satellite and what you see in other observations, is this cyclone that's making landfall in the Pacific Northwest, mostly in British Columbia. Look at how there's a tremendous erosion of the clouds in the immediate lee of the Alberta Rockies. And it turns out, we're just talking about this kind of stuff in 100, and there's strong subsidence in the lee of the Rockies, and you get this big warm bubble at 850, right in that exact location. It's just perfect how it sometimes works out. The weather gods are kind today in my lecture. So, but that's a really obvious gap in the clouds, at least as depicted in the infrared that shows up, and you'll see it is a warm bubble in the immediate lee of the Canadian Rockies today as well. Otherwise, a fairly undisturbed Pacific, and that's been the rule rather than the exception, I think, this winter. Which I don't know if that has something to do with what we're talking about. That it might. It's just been a boring storm system winter in the Pacific Basin, at least the Northeast Pacific Basin. Let's take a look at the radar, Pete. So we have this kind of widespread low cloud, and look at what it's doing. It's kind of scattering showers all over the place, over a wide area. These are all rain, of course, because the reflectivity is a little higher, and then these are snow, as we all know, outside. And it was snowing earlier in the day in Minnesota, but the dew points there have dropped. I think the clouds are probably disappearing there as well. So here's our widespread, low-level showery activity. I can't imagine there's more than a sprinkle of rain coming out of most of these. Occasionally, like here in West Virginia, pretty high reflectivity. Maybe that's a shower, like the icy showers we had yesterday were interesting. And they would come and go in a matter of time. I'm going to guess the coldest temperature aloft is about in this region over Kentucky, Tennessee, and parts of West Virginia. And then there was a second cyclone that wasn't as obvious on the satellite that was getting itself organized this morning over the Gulf of Maine, Massachusetts Bay, and that's got some precipitation associated with it over Maine and parts of maritime Canada. And then you can see some open cellular convective cells coming in the Pacific Northwest upon the landfall of that major cyclone most of which one doesn't see any precipitation with, but this is just indicative of the fact that you're back behind the upper trough axis and you're in the coldest air. So those are all convective instability type showers. So I'm gonna guess like minus 32 or something at 500 there. I don't know what to guess here because I have no experience over the land. Probably something on the minus 25 to minus 30. Let's take a look at, to make it abbreviated, Pete, let's go to the upper level shots. Good. And the super Pete's, we probably should put something like award-winning super Pete's now, I think, because of what's happened this week. Look at that, minus 32 over the Ohio River Valley, and around minus 30 where we had the most, well, this is probably the pocket of air that's now sitting over those most intense convective showers. So minus 32 there, and it was about minus 30 on the coast. This is now the minus 35 isotherm, so probably what we were seeing there was around minus 35 too. So that's nice, isn't it? You got 10 degrees approximately at the surface, minus 35 at 5 kilometers, so the lapse rate's about 9 degrees per kilometer. It's absolutely unstable if you're saturated. And here, in both cases, that's probably close to the truth. Very strong upper baroclinic zone associated with the broad circulation center. The main center of our cyclone, I think, now is over Michigan at the surface, but look at how the circulation and the structure goes well beyond that in scope and scale. And this is kind of tied to the region of attempted development that's going on here in the Northeast. Yeah.
I was gonna, maybe you're about to say this, sorry to interrupt.
Yeah.
But it's interesting, a southwest flow with cold advection.
Yeah, that happens. That happens sometimes, and it is kind of interesting, isn't it? Yep, you got southwesterly flow along the spine of the Appalachians that's characterized by cold advection. And it's too bad we don't have an op right out here. I wonder if there's even a hint of confluence. The one up in Portland makes me think perhaps not. But that's a pretty intense, that wind right there at 500 millibars, and where is that?
It's
Near
Dulles,
DC.
Dulles.
Oh, Dulles, okay. So that's a strong cold advection from the southwest. And one gets the impression that that might have something to do with the maintenance of this baroclinic zone at 500
We're
millibars.
missing Chatham too.
Yeah, Chatham's out of there. Well, that would have been a perfect op for that.
Right.
See that.
And the interesting, just a side
In
note,
Atlantic City.
the reason we're missing some of those soundings is because there's actually a global helium shortage.
Oh, that's right.
And the Weather Service is now cutting back on radiosonde launches because they're trying to conserve helium.
So what they did is they did a targeted experiment to figure out what's the most sensitive region, and then they depleted the observations there. Because Chatham and Atlantic City would have been good today, as we get a storm developing in that region.
I heard from someone in the Weather Service that it was basically those offices ran out first because they were launching so much over the winter. So their supplies were the first to run down, and to finish out launches for the rest of the year, they basically can't.
It's just terrible, isn't it? I mean,
It's also due to the fact that certain locations are too close to places where they can't use hydrogen.
Yeah,
So some of the
yeah,
other
yeah.
locations are far enough away from
okay.
city centers, population densities.
Yeah, we don't want to be sending up Hindenburgs, mini Hindenburgs. I mean, we can't really be doing that. It's not responsible.
Yeah, they can't switch over the lifting gas just on a whim. They have to actually make plans for it, so that's why.
Amazing, isn't it?
that-
And this is not really pandemic related, is what I heard.
Right,
This
it's
helium
long-
shortage is long-term, it's had a long fuse. So it's why we need cold fusion. We can take all the hydrogen, turn it into energy and helium at the same time. It'd be really great.
What a gas.
Yeah, that's right.
You gotta call Steve Wynn and see what he's doing.
Yeah.
Guys in there tossing?
That's, yeah. Look at the scale of this upper vortex.
Edwin.
This thing is gigantic, and it occupies, I'd say, maybe 3/5 of the continental United States and southern Canada. And then the one that's just off the coast is of, notable size as well. So this is an active time, and if we looked, we had time, we could look at the movie. There was a period earlier this week where you could see in the satellite movie a couple of smaller swirls that kind of conglomerated into this giant feature by the end of the week. I think you would see that it was just a couple of little disturbances in the northwesterly flow that got their act together to produce this giant, sort of midwinter type vortex here in early April. So pretty interesting. And colder than normal in a lot of places, but not bitterly cold anywhere is I think the rule with this thing. It's just not, there's nothing left of the cold air by you get to early April. Not enough.
I would disagree that that's a midwinter type. I think that's a spring vortex. Midwinter is more anticyclonic, isn't it?
The only thing I'd say in midwinter, I'd want the center of this thing to be more near southern Hudson Bay. But otherwise, this is in the same longitudinal location. It's a little further south. But, to get this kind of baroclinicity at 500 down to the Gulf Coast, that reminds me of midwinter.
Absolutely.
So that's maybe what made me think that. Let's take a look at 850 Pete. I think we're going to see it. It's not so well put together a thermal structure anymore because the storm has been around for so long. But one does get the impression, right where we don't have soundings, the triple point and development is really going to be concentrated right about at this location. And that turns out to be true. And we saw the reflectivity evident of that some hours later as the storm's getting itself together in the Gulf of Maine. But there's not really a clear-cut thermal structure at 850, except for the cold front, which is a little diffuse once one gets away from this vortex center. Maybe you could argue it goes down through Florida. And the warm front is fairly intense for a while, but there's no real supporting troughiness to keep that going. And then we've got lobes of locally chilly air, I think, and local vorticity maxima that are kind of on the western side of this broad scale circulation. Uniform but strong winds at 850 all the way across the plain. So it's a windy day. It's a good wind image.
John, Portland, Maine, 80 knot wind is pretty spectacular.
Yeah, that's remarkable, isn't it?
Right
Wow.
in the thermal ridge.
And it's +5 there. It's quite warm, yeah, right in the middle of thermal ridge. And that's where we saw, I think at 12Z especially, really intense precipitation was going on right there in the Gulf of Maine. And it's moved up a little bit to the north and east. And then off to the west where we had that second, notable upper trough, and here's the cyclone that's made its way on shore. I think you see actually a better thermal structure with this one in terms of the cold front. Right in there, it's about 10 degrees of contrast that seems continuous all the way into Alberta province. And it's even got a little bit of, not really an obvious wind shift, but a little bit of a wind shift associated with it at 850. So that's an interesting storm. And look at this bubble, +14 at Calgary. And everywhere else is like, Spokane's +14, but everywhere else is, -2, 3, 9, and so on. So this is a warm bubble sitting right where the subsidence is occurring, and a little bit of troughiness, characteristic of a lee trough. I think that bleeds southward into the United States Rockies in both Montana and Wyoming over the course of today and into tomorrow, because the flow is going to be pretty strong across even the northern Rockies in the U.S. Okay, let's take a look to see what the flow at upper levels looks like on top of that. 300 millibars. Thanks, Pete. So here's the broad trough, pretty intense jet where we saw the stronger baroclinicity on the eastern side than the western side. There's the second strong trough. And the flow, there's the Canadian Massif, Banff and Lake Louise are right like that. The flow is at 300 millibars, a little higher than mountain height, but going straight across it. So subsidence in the lower troposphere is right over the plains of Alberta, and it's really warm there today. Warmer there than I think it is in some places as far south as the southern U.S. So it's all subsidence warming. But a really undulating flow here, pretty wavy flow at 300 millibars. And I think it looks roughly the same at 200. So a giant upper trough. So I think that's all I have for the current ops. And if you want to talk about the forecast, Michael, or are we going to go to the severe weather threat first?
I'll do it quickly.
Okay.
So, I'll hold off on the other things that I have. We'll just go to the, we have a Sol, where is it? Oh, MF5 forecast. And go down to the meteorograms, everyone's favorite
Oh, yeah,
starting
the
point.
meteorograms.
So for the forecast, this weekend is looking somewhat improving in terms of, if you like, warmer weather, drier weather, we'll see that, and then we'll get wet again by the time we get to Monday or Tuesday. But we'll see that we'll get the forecast. So nice warming trend that we see in the forecast for temperature. Dew points slowly beginning to increase once we get past midday tomorrow. And then the light precipitation we're having today, the sprinkles and such are going to continue through the afternoon, but then that's about it. And then basically maxed out on our preset, at least for the next 60 hours from 12 to this morning. Let's look at the time height section. What you're going to see there is this really deep upper trough, tropopause undulation. I wouldn't say deep, but there's the last vestiges of it as it moves by us later on today. With the 1.5 PV surface, the dynamical tropopause showing up here. And we see subsidence as it begins to lift out. So this is sort of, if you look at this negative vorticity advection, negative potential vorticity advection, that's going to be associated with subsidence. And I thought a curious aspect of this is a lot of this warming that we see here. You can see the isotropes beginning to subside because of the subsidence. It's interesting that the warming that we're seeing here isn't due to, in an obvious sense, any geostrophic warm advection occurring in this column. It's just, I think it's largely due purely to subsidence. You don't see a variable wind in the mid-troposphere, which I think is kind of a nice, curious feature of that. Here's this moist layer that's trapped beneath this stable layer that's under the upper trough. I think one of the reasons we see this large swirling pattern of cloudiness and the light precipitation that's embedded in it is, again, because you have this large-scale geostrophic circulation over a surface, frictional surface, you're getting Ekman pumping, you're getting slow rising motion, those air parcels are beginning to reach saturation. You're getting a deck of clouds that's fairly thin, stratus that's forming, and it's producing light precipitation. If there's any modest forcing, an upper trough embedded in it, or some local convergence or divergence associated with some other phenomena, some other process, you might get some enhanced precipitation. Or if it's just colder, as John pointed out, you might get a little bit of sun. Quickly, that cold air aloft is going to destabilize you. You get more convective type showers. So that's underneath this broad swirling cloud mass. Looked at a sounding from Green Bay this morning. You can see that it's up to about 700 millibars or so. It's pretty close to being saturated in those soundings. The temperature dew point soundings kind of spread apart, and so that really indicates that the moist layer isn't super deep over us, and where you expect the clouds to occur, not going to be persistent. But in any case, that all ends once we begin to move toward tomorrow afternoon. So by the time we get to tomorrow afternoon, we get some nice mixing. It's going to be a well-mixed layer forms over us, and we're going to probably approach 50 degrees. By the time we get to Sunday, maybe into the mid-50s, or even warmer as that occurs. But fortunately, we see assets occurring. There's another weather system that's about to approach. Let's quickly look at one quick thing. I want to look at the 305 to 315 PV animation. And one of the couple things that I'll note, a little bit of a puzzle here. You'll note here we get this little area of negative PV that just forms rapidly and then disappears, which I thought that's kind of a curious feature. We can step through that. But the first thing that's most conspicuous on this map is this large swirl, which is the large vortex that's over us that begins to lift into Canada. Lower PV arrives from the west to northwest, and that's going to be associated with the increasing temperatures and subsidence in the troposphere. And here's the feature that John mentioned that's arriving on the west coast this morning that produced those showers in the Pacific Northwest. And that's going to be a feature that plays a role in some of the weather that's going to be occurring in western Minnesota over the weekend. And then eventually, as it approaches us in the southern plains or the central part of the United States, could be interesting for some active weather, which Isaac and Caleb will be talking about in just a moment. Let's, if we stop this and go to...
So that negative PV patch,
Yeah.
I would guess that it would be traceable upstream to some convection.
Right, and we'll see
Goes
that.
through it, so- Oh.
Yeah, so you're absolutely correct. So at this point, this is at 48 hours, you look at this map, I mean, you can see there are a few little waves, if you will, of the potential vorticity. They're pretty modest in terms of their structure. The dynamical trough is pretty, well aligned here. But if you step forward by just 6 hours, boom, we get this area of very low potential vorticity that just emerges in this. And I haven't done the tracing in terms of the timing of this, but these winds are, 80 knots or so. And where's this going to end up? If it's perfectly conserved, we'd expect this patch of low or even negative potential vorticity, or close to zero potential vorticity, should still be on the map, this isentropic surface 6 hours later. So if we go ahead six more hours, it's just totally gone. I don't know if it's been ejected out of the domain. I kind of doubt that. But that's just a surprising rapid turnaround, because normally you'd see this and you'd just expect it to continue. At the same time, we're seeing continued precipitation in this region. So let's go back up to 48 hours in the forecast surface map.
They might go from blobby to filamentous and be below grid scale.
That's a fair point, that if we begin to stretch it out and it gets diffusion of the model, numerical or otherwise, that could actually help bring to that.
Cooling on the cirrus shield or something? I don't know, that seems to happen.
That could
Be too
happen.
fast, that seems to operate.
Right,
too
over
fast.
6 hours, I think
Yeah.
that might be a little bit too fast. But here's this area of precipitation that's developed over parts of South Dakota and western Nebraska. Okay, just for purposes here's that southwest flow over us that warmed us up on Sunday. But if you go ahead another 6 hours, look at the accumulated precipitation, that coincides to the same time we saw that. Okay, this is significant precipitation that's occurring in the high plains, and that's in the area above this is where we saw the loss of potential vorticity. So whether it's convective or extreme stratiform precipitation, that's where we're losing the PV. But again, we can see this nice warm reduction ahead of us. If we go to 60 hours at the end of the forecast, we'll see what that structure looks like. So nice, well-developed cyclone moving into southwestern Minnesota, strong warm advection ahead of us. And so by Sunday evening, clouds are going to be increasing to our west, and that sets the stage perhaps for some interesting weather in the southeastern part of the United States, maybe Monday and Tuesday. But at this point, I'm going to let Isaac and Kaylin, if you want to come up and talk a little bit about the potential severe weather threat early next week. I'll turn it over to you.
Thank you. Sorry. Let's put this in here, sorry. Perfect. All right, so the first 3 days of next week look like there's a pretty significant severe weather threat shaping up, so Kim and I thought we'd give a little bit of a brief synopsis on that. Right now I've got the day 4 through 8 outlook from the Storm Prediction Center pulled up here, just to give kind of a broad overview of where the risk areas might be centered. As you can see, so central southeastern plains here are the main areas where it's going to be shaping up. If you want to pull up the yesterday, I knew at least yesterday there was a day 7 outlook issued for southeast Oklahoma, eastern Kansas, that area, which is a relatively rare occurrence. I've got this nice plot from Iowa showing the average number of days per year that a day 7 severe outlook of any flavor is issued. So as you can see, it's kind of the area that you would climatologically expect it to be, but average occurrence not much over once per year in this area, so a pretty rare event in terms of the certainty that the Storm Prediction Center and confidence they have in some form of severe weather shaping up across that area is at this point. So now I'll give just a little bit of a brief overview of the synoptics for the event. So we'll start here with the 250 millibar, 250 millibar height and wind valid Sunday night, so the day before the first risk outlook. So we've got this broad upper low over southwestern Canada and pretty zonal flow across most of the continental United States. As we move across the period, this trough will deepen significantly. If you want to take me to 0Z on Tuesday, that'd be wonderful. You can see this upper trough start to amplify a bit, and you get a response in the flow across most of the risk area. A little bit of a weaker upper flow. This is 0Z on Monday, so day 1 of the 3-day kind of severe weather outbreak. If you want to take me to 0Z on Tuesday, that'd be great. You can see significant amplification at this point in the period. Still a little bit of a weaker flow over this kind of portion here where the main risk will be, but by Wednesday, as this trough begins to eject, in between 18Z and 0Z, you get significant flow at least 200 millibars there, supportive of some very strong storms. If you want to go to 500, we can do a kind of a similar walkthrough. Whenever we the 0Z Monday would be great. Perfect. So again, a similar kind of pattern at 500 millibars to the 200 millibar map at 0Z on Sunday. We've got a lead, a little shortwave that's ejecting out over the upper Midwest, and pretty zonal flow west of that. I'm going to go 24 hours in the future. That's wonderful. Again, you can see some amplification of the trough. We got a nice positive tilt trough starting to amplify here, and good strong, 60, 70 knot, 500 millibar flow across much of the risk area there at that point. I'm going to go to 24 hours in the future. That'd be great. Yeah, and so you can see this. We've got this very, very deep trough with a very impressive jet streak at the base of it, and again, pretty impressive flow across the risk area again. And then you can go. It's looking like Wednesday is the day of highest potential for some significant severe weather. As you can see, was this really deep wrapped up low is in the area there, and associated extremely strong upper flow in the 100 knot region. So pretty impressive jet streak there, and you will see that it's associated with a pretty impressive jet streak at the lower levels as well. If you want to take me to like 850, that'd be wonderful. So if you want to take me to Monday at 0 or Tuesday at 0, that'd be great. So first day of the risk area, a little bit weaker. Still a pretty impressive low-level jet here in the 35 to 45 knot range, associated with low over the Rockies here. You can see as you go into the evening, rapid increase in the low-level jet strength again. And on Tuesday and into Wednesday, really impressive jet by 0Z on Thursday, associated with this really impressive low there. Somewhere in the 50 to 60 knot region, which is quite an impressive low-level jet. Do you want to pull up dew points then? We can talk about that too. And the method for forcing of storms on most of these days, or all 3 of the days, I guess, is a pretty impressive dry line that kind of. That'd be great. So you just go to. Perfect. You can see pretty impressive dry line associated with mid-60 dew points across southeast Oklahoma and southeast Kansas. And so you'll get storms potentially along the dry line every day. You've got a nice little low pressure system that just kind of sits over the Rockies and reloads the warm sector with impressive moisture advection every single day. And again, you know, another really impressive sharp dry line here over eastern Kansas and eastern Oklahoma on Wednesday that should hopefully provide some forcing for some.
2 Fahrenheit?
Yes. 63. Yeah, that's great. So really, really impressive.
What does the sea level pressure look like at this time?
Let's see. It looks like we're down to about 998.
I just can't see the structure
Right,
along
yeah.
the dry line with all those colors.
You want to pull up a little closer sector if you want to. So we just have that low kind of sit over the Rockies there, just eventually eject.
985.
Yeah. And pretty impressive low level southeast Julius there should aid in some.
But is the dry line right along the pressure trough?
I think
to the
it's
south? It's hard to
yeah.
see. It's hard to tell. I think it is.
Yeah, I think you can see the bend in the isobars there is where the dry line is. If you want to, yeah, we can zoom in a bit. And Kaylin will talk a bit more about some of the mesoscale features and things that we'll be seeing, as well as some of the teleconnections. It's been a pretty well forecasted event. Further, yeah.
If you look at the 200 millibars, is that?
Yes. Let's, can you pull up 200 millibars when we get a chance?
Also, if you ask it this.
So yeah, we can see the, I think the dry line's right along here. You can see the wind shift actually there as well.
Yeah.
So again, like eastern Kansas, eastern Oklahoma into western Arkansas and western Missouri.
Just a quick interjection, this is what I was talking about earlier in the spring with drought conditions really affecting how far east the dry line can move. Obviously the cyclone dynamics are first order dominating here, but there's still severe drought across Texas and Oklahoma. So there's pretty much next to nothing impeding the transition of the dry line into eastern Oklahoma and Kansas.
Because typically you'd be seeing it much further west this time of year, correct? Excellent. Yeah, so then, yeah, you can see the surface level way up here, and then you can see the bend in the isobars here.
Yeah, so it's pretty coincident. So
Yeah.
I always wonder what it means to say that the dry line forces this, that, or the other thing. There's no
Yeah.
real dry dynamics at the dry line. There's no
Yeah.
ascent being forced there, but there's a huge dew point.
Gotcha,
A difference
yeah.
in fuel for whatever is going on at upper levels between, along the thing. So they fire up along that boundary, perhaps because wider spread forcing only ignites things on the moist side, you know.
Yeah.
So.
Well, there's also the fact that the downdraft is really enhanced with dry air, and that creates a two-way system. You've got accelerating air down and accelerating air up, which is a bit of a horizontal vortex.
He
The down,
testified
and
that.
you know, you're pedaling both.
Yeah,
pedals
okay.
With the bicycle, so
Yeah. So you do
dry
get
lines can help quite a bit.
his response to some other forcing.
Yeah.
Yeah, okay, I see. I hadn't thought of that.
You wanted to see the 200 millibar winds?
200 millibars.
Yeah.
That is very dramatic. That's a great looking piece. I mean, bad for people down there. But
Can you look at one of the continental scale?
Yeah, for
I
sure.
just had the idea that the subtropical jet was way south.
There is an interesting interaction with the subtropical and polar jet.
Oh, they're
here, yeah.
definitely-
Yeah,
yeah.
the subtropical jet is way down there.
Yup.
And that means you're in a region of somewhat throughout the day anticyclonic shear on the north side of that. So the outflow will be
The north side will-
compromised. And the effect of that, I think, is that if the lower level dynamics look great.
Yeah.
So I think you'll have supercells,
Yes.
but I think they'll be isolated. I don't think they're gonna be able to have a lot of them.
Yup. And Kaylin was going to talk. Do you want me to go to soundings, or do you want to start with teleconnections?
Just go to teleconnections.
All right, sounds good. Kaylin's going to talk about the teleconnections
Yeah.
here.
So this year, this year we've been fairly active with regards to severe weather. This is the amount of tornado reports we've had since the beginning of the year. The red line is what we've had this year, and the black line is the average. And these other dotted lines are the years since 2005. And so far this year, we've had 427 through the 7th, which is the 4th, I believe, highest to date in the last 15 or so years. Just to go and show how active this past spring is with multiple violent and strong tornadoes in the past week alone. And that'll continue next week. And for this current event, this year, it's been a La Nina year with negative anomalies in the surface temperatures in the ocean since basically last year. And this is a second-year La Nina, which we typically see a higher amount of tornadoes and severe weather. The last major second-year La Nina was 2011, and of course we had the April 27th, May 11th, May 3rd, or something, May 24th events that were pretty significant in that year. So hopefully we don't see that large of events, but just the negative anomalies here and negative PDO in combination create a favorable pattern
How do they do
West
that?
Coast troughs. That is beyond my knowledge. I just know that them two in combination with the negative PDO creates blocking, something Grant may know more about, but it would provide more likelihood of a trough forming along the West Coast. And with that, you get more severe weather events.
I'm gonna just go back to the tornado reports here, just to compare it to the last second year La Nina, which is 2011 is the, I believe it's this line as well.
Yes,
so,
the maximum.
Yeah, so you can see the April 27 events later in April. It's a very active April as well. So
That's your Joplin?
Yes. So this was, I think Joplin was around here, and then you had the Piedmont and Reno.
The one in Alabama was late April, wasn't it?
Yes, this was
April 27,
and then
yeah.
April 14th was, or 13th.
so similarly very active.
Preceding April 27th was also severe weather in the Carolinas, which kind of like what's been happening this week, so a lot more East Coast activities along those.
Sounded now?
Yes.
Excellent. So,
One last thing. This event has been pretty well forecast with the MJO moving into phases 3 and 4. With the jet was quite protracted or extended over the past couple weeks, as we saw in previous weather watches. It extended basically over the western U.S. But as it retracted, it built in a trough, or will build in a trough over the next couple of days, which will be the main reason we see the severe weather. So here are the soundings.
Can I ask a question, Keelan?
Yes.
Do you know what the antecedent conditions are for the deepening of that trough off the west coast? Does it come out of the northwesterly flow?
I believe it's a combination of a couple things, northwest flow and tropical forcing from the MJ moving to 3 and 4, but beyond that, I'm not sure.
Okay, yeah, because I didn't know about this, and I would have looked at that myself in my part of the discussion. It would have been a nice addition, so thanks.
Grant?
So what you get is when the La Nina is, because I've done no analysis of this, but this is just the trends that I know from looking at this data a lot, is when you have the La Nina extended that far west, then your block's going to get, your average blocking pattern is going to be a bit further west as well, more into the Pacific Ocean, so that's where you're going to get that trough on the eastern side. Typically with La Nina years, you get increased blocking in that region, and just from the composites that I've done, you get a really sharp temperature gradient right about in that lower portion of the where the severe weather is occurring in the central United States. You get a really sharp temperature gradient there, where you have really suppressed temperatures to the east of it, and then normal temperatures in Mexico and then into the southwest.
Excellent.
Yes. All right, so this is a area average sounding for Wednesday. The red line gives your temperature.
Is this Wednesday?
Oh, Tuesday, sorry.
Yeah.
The green line is your dew point, and this is area average. So within this box between Kansas, here you have Kansas over here, Oklahoma here, and then this is northern Texas. This is the average sounding with the outlines of the maximums for the temperatures and the dew points in the highlighted areas. And we see that we have the partial trajectory, partial trajectory here in the dash line. And you can see that near the surface you have very warm dew points and temperatures, and as you go up, you get unstable air with Cape values approaching 1,500 to 2,000 joules per kilogram. And with this, we got good veering with southerlies at the surface, going to southwesterlies and nearly westerlies as you go up. And as in the photograph, you have good streamwise vorticity for any supercells that do develop.
Also, I'll note the kind of warm nose you see around 700 millibars, 800 millibars would, in my estimation, be more conducive for supercellular development along the dry line as opposed to more linear systems. It's tougher to get effective initiation in a regime when you have a little bit of inhibition above the surface such as that. So I would say supercell would probably be the dominant storm mode on all three of these days, and I think that's what the forecast has been for that. We can go, or I guess we're about at time now, so I think we'll call it there maybe.
I get the impression, you didn't make a Wolf Richardson number calculation, but I'm wondering if the shear is a little too high to support this.
Yeah,
Because the tape isn't that big.
yeah,
Well, in area average soundings, you have the Cape average from the most pristine line next to the dry line and more further east where the Cape is less. So these Cape values are a bit lower than what is directly where the
I think you
convection.
need Capes closer to 3 to 5.
Yeah, it'll be a bit
Yeah.
higher. This is just the area average setting for a GFS, which tends to be low biased in advance.
Euro had a much more impressive.
Once we get in closer to cam ranges where the HER and NAM get closer, we probably see 2,500 to 3,000 as you mentioned. But this far out on a low resolution GFS global model, we'll definitely hold all to Cape for now. Any other question?
I just would make a comment that to the extent that the subtropical jet creeps further northward, because I think if you took a cross-section through that jet feature of Thursday morning, you'd really see two separate jets with the subtropical jet to the south. If it makes it a little further north, then what also happens is a slightly warmer air comes in around 200 to 150 millibars, and you increase the area, the positive area on your sounding. And that's a dramatic difference. I mean, it can really change something that is sort of run-of-the-mill outbreak to something that's catastrophic. I think Roy Christensen showed that happened in the April 27th, 2011 case.
We did that study of major outbreaks, and we found that 20 major outbreaks we studied, every single one of them was associated with a subtropical jet to the north, west and north.
Yeah, because you got the tropics all the way to 150 millibars, and that changes that top part of your
You get the subtropical
sounding.
jet in play there, then you're in, bad city.
Yeah.
Chase.
Excellent.
Thank you for coming.
Well, thank you.
Thank you guys, that was great. Nice job, fellas, that was great.
Thank you.
Yeah, good job,
Thank you.
thanks.
It was a good time.